So in this video, I want to talk about, kinetic energy, finding kinetic energy, rest energy, total particle energy, and essentially, okay? So we know that the rest energy of any particle, that's just equal to mc squared. Yeah, the rest energy of any particle is equal to mc squared. Now, the energy of a total particle, so the energy total of a particle is equal to gamma mc squared, which is also equal to mc squared plus k. Okay, so the energy total of a particle is just gamma mc squared, or we could say it's mc squared plus k. Okay, so we know how to find the kinetic energy. We know how to find the rest energy. We know the energy of a total particle, which is equal to gamma mc squared, or mc squared plus k. And the kinetic energy of a particle, well, this is just equal to 1/2 mass times velocity squared. And this is only if your velocity is less than the speed of light. Okay. Now there's another way to relate there's another way to relate your kinetic energy. And that's the idea of the kinetic energy of a particle. You could also relate it to momentum. That's equal to the momentum squared divided by 2 times the mass of that particle. Okay. So these are some of the ways that we relate kinetic energy and rest energy, etc. Okay, so I have this kind of worksheet here, and I wanted to go over it to kind of see where we're at and to kind of get the concept down about the idea of these types of problems. And so there goes my calculator. Okay, so let's look at these problems. So we have a proton here is moving with the speed of 2.8 times 10 to the 8 meters per second. Okay, and the question might ask, the magnitude of momentum of the particle is what? Well, we know the general form of the momentum is gamma mv. Yeah, and this gamma now is important because we're actually traveling close to the speed of light. And so if I want to find the momentum, I gotta calculate gamma first. And we know this is 1 divided by the square root of 1 minus velocity. Yeah, 1 minus the magnitude of the velocity divided by c, and we square that. So this is what gamma equals. And so I'm just gonna just plug in my calculator. So I'll take the square root of 1 minus velocity squared, which is 2.8 times 10 to the 8. And I square that. Well, not square that. I divide by the speed of light times 10 to the 8, and then I square it. That gives me some sort of 0.359. So I take 1 and I divide that by my answer. So I get my gamma to be 2.785. Okay. So we know the gamma is 2.875. So this is gamma. What's the mass of a proton? It's approximately 1.7 times 10 to the negative 27 kilograms. And we multiply that by the velocity now, which is just 2.8 times 10 to the 8 meters per second. And so plugging all those in, so we're like a 2.785, 1.7 times 10 to the negative 27 times 2.8 times 10 to the 8. I should get approximately 1.33 times 10 to the negative 18 meters per second, kilograms times kilograms, magnitude of momentum. Okay, but this is not what the video is about. I just wanted to show you. I just want to put it in. Okay, so now the question might ask, okay, well, what is the total energy of this particle? Well, at this point, we're not given a kinetic energy, and so we know that the energy of a particle, or the total energy of a particle, is equal to gamma mc squared. We can't use mc squared plus k like we showed, because again, no kinetic energy is given. And so we know what gamma is. Yeah, we know gamma is 2.785. Well, what's the mass? 1.7 times 10 to the negative 27. Okay, and we're not going to worry about units right now, and we're simply going to square the speed of light. 3.0 times 10 to the 8 meters per second squared. Okay, and when I plug all that into my calculator, I should get 4.26 times 10 to the negative 10 joules. Okay, so this would be my answer for the total particle energy, the total energy of the particle. Now the question might ask yourself, okay, well, what is the kinetic energy of this particle? Well, think about it. We know the kinetic energy is 1/2 mv squared, but we can make this easier. We know the energy of a particle, well, that's just equal to mc squared plus k. So therefore, we could actually solve for the kinetic energy. And so we know that k now will actually be equal to total particle energy minus its rest energy, mc squared. Okay, the good thing is that we already found the total particle energy times 10 to the negative 10 joules. And all we need to do is find the rest energy. So the rest energy will be 1.7 times 10 to the negative 27, its mass, times the speed of light squared. Okay, and that would be minus 1.53 times 10 to the negative 10 joules. And if I plug this into my calculator, if I take if I take 4.26 minus 1.53, I should get about 2.73 times 10 to the negative 10 joules. Okay, so this is how we relate total kinetic energy, kinetic energy, total energy, and rest energy all together. Now, I want to point out something important here. What if we're given a problem like this? Okay, so it says a ball whose mass is 2 kilograms travels at a constant at a velocity of 0, -3, and 4 meters per second. What is the kinetic energy of the ball? Well, remember this, okay? Do not make this mistake. The kinetic energy of a particle is 1/2 mv squared. Notice that anytime we talk about energy, we talk about joules. They're not vectors, okay? Energy is not vectors, and so in order for me to do this, we know the kinetic energy of any particle is just 1/2 mv squared. But in this case, I have to take the magnitude of this velocity, okay? And so if I take the magnitude of this velocity, this then becomes the square root of -3 squared plus 4 squared. And the magnitude will be equal to about 5. So the kinetic energy is 1/2 the mass, which is 2 times the magnitude of velocity. Okay. So if I take 25 squared, if I take 5 squared, that gives me 25. If I multiply that by 2, that gives me 50. And if I have 50, that gives me 25. So that gives me 25 joules. Okay, so be careful. Anytime your velocity is given as a vector, you always want to take the magnitude of that. Okay, because kinetic energy is a scalar. It's not a vector.